Hey, gang. Hope everybody's doing okay, staying warm, dry, all that other fun stuff during this slight snowstorm and whatever. It's kind of a bummer that we didn't get to do this again today. Maybe not so much of a bummer for you guys, but definitely a bummer for me. So, just starting here, this problem set was what I gave you to check for your understanding during our last class. I posted or I'm posting the worked out solutions or explanations for all these problems here. So take a look at them. When we come back into our next class, we'll open up with some questions, see if you guys have any issues. If you do and you don't want to ask during class, then come during office hour or set up a time to meet with me virtually. That's cool too. But just make sure that you work on these things. Like I said, I'm not going to count it. This is for you to see how well you understand how the lesson went. Stay on top of it. If you need help, let me know. I'm here for you. All right. So really quick, I'm going to go through what I had planned for today's lesson, which is technically section 10.2 in our textbook. Uses the fundamental counting principle. This would have been a hell of a lot more fun in person, but we'll run through it in person a little bit on Monday, and then we'll really get through hammer out 10.3. So the fundamental counting principle, I kind of call it the Chipotle principle, right? Because when you go to Chipotle, you have so many options. And it's how do they figure out how many different possible options you could have at Chipotle or in any restaurant, in that matter, when you start talking about different things. So, for instance, if you look at the menu at Chipotle, and I kind of just went a little bit basic here, imagine you had to select one of the four ways. I know there's other ways you could get food there, but let's just get over it and pick one of the four ways here: burrito, bowl, salad, or tacos, right? Then you could get any of these types of meats or the tofu, which if you're picking that, good for you. Veggies, stuff like that. So imagine you had to pick one of these, right? And then you had to pick either white rice, brown rice, no rice, black beans, pinto beans, no beans. Pick a salsa that goes onto it, all right? Guac or no guac. And then these things they just go on without question. If you don't get them, then I don't know. We'll have to talk about that. But I think cheese, sour cream, and queso is not even a no brainer. So we're just not even going to count that. All right. Anyway, if we look at this, right, if we try to sit here and do a tree diagram, if we try to sit here and draw it all out like we were doing in the last class, so do a product table that can't even be made, it's going to take us forever. It's going to be impossible. We're just not going to do it. We're going to forget something. There's no strategic way of doing this. However, if you start small and start thinking, right, if you were to pick a burrito, then there's all these different types of meats, right? So every time we work our way down the line, we could change one. So what's happening is instead of sitting there and drawing it all out, like I said, what we could do to simplify it is we could multiply the number of options we have from each one, right? So in the first one, we have four options. The second one, 1, 2, 3, 4, 5, 6. We have three options, 1, 2, 3, 4 options, 2 options. Again, this is standard. Everybody gets it. If you don't get it, we can't talk, right? But what you do is you just multiply those numbers together. As I got my phone out to do my calculator, I'm going to take 4 times 6 times 3 times 3 times 4 for the amount of salsas and times 2 for guac or no guac. So guaranteeing one item for each one of these, what you should get is 1,728 different options, all right? Which if you divide by 365, it would take you almost 5 years to get all these different combinations if you were to go to Chipotle once a day. Again, if you're going to Chipotle once a day, not a bad choice, but get out more. Anyway, here's it's kind of like wrapped up in an idea here. All right, that's very mathy to read. I like to get away from the math. So multiply the amount of each category together in order to find out the total amount of ways that task could be completed. Okay, so this could be given to you in a variety of different ways. You're going to see it in the problem set that I'll give to you here. We'll talk about a little bit more on Monday. Okay, so for instance here, finding digits, right? How many two-digit numbers there are there in our base 10 system of counting numbers, right? So when we talk about two-digit numbers, if we start with a 0, that's not a number. Like that's not a two-digit number, I should say. So 04 is not, right? So the first digit would have to be a 1 or greater than that. And then we're going to go all the way up to 9. So technically in that first spot there, in the 10 spot of the units, we could have 9 different options. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Can't have 0. 0 can't be the first one. But the second one, we could have 0, right? Because 10 is a two-digit number. 1, 0, 4 is 0, so 0 works there. So if we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 10 different options. So in order to figure this out, we take 9 times 10. We multiply the two parts of the task together. 9 times n gives us 90. Find the 2-digit numbers that do not contain repeated digits. So this one, again, we're going to get a little different, right? If there's 9 to start it, right, we got to have 1 through 9 to be there in the 10 digits. Then we go to the second digit. Okay, so let's just say we pick, I don't know, 3 as our first digit. Well, what can't be in the second digits if we don't want any repetition of digits there? We can't have a 3 there. So when we look at our options, that 3 is gone. Now we're at 0, 1, 2, 4, 5, 6, 7, 8, 9. Okay, we only have 9 options. So we had 9 options for the first number, 9 options for the second number. That answer is 81 by multiplying 9 times 9. How many non-repeating odd 3-digit counting numbers are there? Okay, so then what you got to figure out is how many things could go into the first unit, right? The first unit is 100 digits. Again, if we put a 0 there, it's not a 3-digit number. Okay, so we have 9 options for the first digit. We go to the second digit. We can't repeat anything. So whatever we used in the first one, we can't use it in the second one. So it's down to 9 again. Okay, but now what's going to happen is we want it to be odd, and we want that odd number to not repeat. So this one's going to get a little bit more complicated because we have a lot of stipulations. So I'm going to pause here for a second. Okay, this is what one of the things we'll bring up on Monday, because I feel like if I'm trying to explain it to you here, it's going to be a little bit difficult to translate into real life. So we'll kind of pause on this one and go back to this on Monday. Not a big deal. And we'll talk about some strategies with some stipulations there. All right. Hopefully I didn't lose you already. So we could do something with license plates, right? With a pattern like this: letter, number, number, letter, 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 right? We could talk about different stipulations that go here. Remember, there's 26 letters in the alphabet. There's 10 digits to use, 0 through 9. Depends if you could repeat, can't repeat, and so on. All right. So we'll talk about that a little bit on Monday too. Now, last class, this was really awesome. A couple of people brought up the word factorial. Okay. Again, this would have been really awesome to talk about in person, but I want to at least get this introduced to you guys, and we'll touch upon it again Monday. When you talk about how many different ways you could arrange a certain amount of items, right? So, like, let's say if we were to line up in a class, right? I probably would have started small, bring up 6 of you, start putting you in order, right? The way you figure that out is like, okay, if I've got 6 people, there's 6 different ways that first person can line up. Then afterwards, the next person, there's only 5 people left to choose from. So there's 5 different ways to line that up. Then 4, then 3, then 2, then 1, right? And if we're going to multiply all those different ways we could do it together, right? We do 6 times 5 times 4 times 3 times 2 times 1. That's factorial. You start at a number, whole number, and you start working your way down all the way to 1, multiply all those numbers together. That's what factorial is. We use the exclamation point, okay, as an operation in that, right? Just like a plus sign and minus sign, the exclamation point is an operation. So that's not n, that's n factorial. All right, and it's used to find the total number of distinct arrangements of n objects, right? If I had 5 objects, we do 5 factorial. We had 10 objects, 10 factorial. Okay, so we calculate, we start with the number, right? And we start working our way down, like I was saying, 5 times 4 times 3 times 2 times 1. Again, here's the mathiness of it. Here's the English part of it. Okay, 0 factorial, think about what that would be, right? Because if we're going to go all the way down to 1, 0 is less than 1. So give that some thought. You might be able to figure it out, or you might know it already, but we'll talk about that more on Monday as well. Some helpful hints with factorial quotients. Okay, if you start talking about things, get out of the way. I can't hide it. Anyway, we'll talk about this a little bit more because this gets a little crazy. But if you start talking about sometimes expressions of all factorials can be easy to evaluate. We're going to get some situations where we're going to create quotients with some factorials. We're going to be able to cancel some stuff out because of how it multiplies down. So like, for instance, 10 factorials, 10 times 9 times 8 times all the way down, right? So it's really like 10 times 9 times 8 factorial. And we could stop there. And then underneath it is 8 factorial. And any number divided by itself equals 1. So we could get down to 10 times 9. We'll talk about situations where that happens. Okay, and this would be one of them. Again, through the computer, you're not going to get it, and that's fine. Just the explanation is not going to be good enough. I think we really need to see it in action with each other. Okay, if you get around to it, if you totally get around to it, here's some check for your understanding problems that you could take a look at. If you want the answers, send me an email. If you're not going to work on it over the weekend, totally fine. I'll give it to you next week. You know, like, we'll make this work, guys. Okay. I want to be there for you. I want to help you. This is not ideal. I know a lot of us had to do this through COVID and stuff like that, and now we're back doing it again. It stinks, right? So I want to take advantage of the in-person class as much as possible. But if you're like, hey, you know what? I got the book. I could work on some stuff. It's great. Here's the problem set. Okay. If you haven't gotten the book yet, get the book. Okay. A lot of the stuff I'm going to give you guys is out of the book. Get the book, rent it, and then send it back unless you want to keep using it year after year if there's that much interesting stuff in it. So, hope again you guys are doing okay. I had a great class, the last time. I hope you did too. Looking forward to the rest of the semester and better weather so we can be together and work some more. All right. If you have any questions, if you need to meet, if you need to talk, just send me an email. All right. And then we'll figure it out as far as what time. I'm more than happy to be flexible with the timing. I know I have the office hour tonight, technically 6:15 to 7:15. But if you want to meet tomorrow, Friday, over the weekend, whatever, virtually, we can. Let's just set up a time that's cool. All right. Thanks, everybody. Have a good one.